Yes, good evening everyone. Welcome to ACE Online. Today we are going to see here some PYQs related to ISRO examination, and at the same time, as much as possible, I will try to cover more number of questions so that many points regarding entire machines you can also see here. Okay, now see this. See the first question here. It is as compared to delta delta bank, the capacity of open delta, okay, is dash percentage. So initially delta delta transformer is there, now it is converted to open delta. Then what is the percentage of this? So when delta delta converted into open delta, definitely capacity will be reduced to what? 57.7% it is. But if the same question is asked open delta to delta delta, then capacity will increase here. And how much percentage increase it is? Now the answer is 73.2% increase. Remember this. Delta delta to open delta capacity reduce it to 57.7, but open delta to delta delta capacity increases by 73.2%. Don't confuse in this. Next, see this question. The applied voltage of a certain transformer is increased by 50% and frequency is reduced by 50%. Voltage increased by 50%, frequency reduced by 50%. The maximum core flux density will be dash. So we know the maximum density is related to what? Voltage to frequency ratio, no? And here given voltage increased by 50%, frequency reduced by 50%. Then what is the new values? 50% increased means what? So simultaneously try to give your answer also so that it will be little interested. Now voltage increased by 50%. So new value is 1.5 V1. Frequency reduced by 50%, that is 0.5 F it is. Then what is this value? So this is 3/2 and 1/2, it is 3 times of previous. So density increased by 3 times it is. So the answer is option A. Next question. Try to answer this. Distribution transformers have core loss dash. Core loss or iron loss is dash. More than full load copper loss, equal to full load copper loss, less than full load copper loss, negligible compared to full load copper loss. So what is the relation between iron loss and full load copper loss in a distribution transformer? If you remember, in a power transformer, the full load copper loss is almost equals to core loss there, because we design power transformers always to produce maximum efficiency at full load condition, because it is always operates at full load only mostly. That's why we design like that, and according to maximum efficiency condition, copper loss, we have one relation, no? X square times of full load copper loss equals to iron loss. So from that equation you can consider for distribution transformer it is. Power transformer means X equal to 1 there. Then what is the full load copper loss equals to iron loss. But for distribution transformer, that X is approximately 0.7 to 0.8, 70 to 80%. We will get maximum efficiency, no? So 0.7 approximately if you take into full load copper loss is equal to core loss or iron loss. Then from this, what is 0.7 square? Approximately 0.49 or 0.5, that is 1/2 it is. So the iron loss is here approximately half of full load copper loss it is. So what is iron loss? Definitely less than full load copper loss, not always half it is. So for example, if you take 70% full load, it is the relation. Otherwise 80% if you take some other relation we get. So definitely iron loss is less than full load copper loss always. Next question. See this question, read it. Non-loading heat run test on transformer is performed by means of dash. Non-loading heat run test. So which one is called heat run test? Synchronous test is called heat run test. Okay, non-loading, why? Because here in the Synchronous test we don't connect actual load. So in the same Synchronous test we will perform OC and SC test back to back there, so that up to maximum heat generated in that, and based on the maximum heat produced we can decide the kVA rating of transformer, no? So that's why it is Synchronous test only. Next time, read this question, try to answer this. A shunt generator has critical field resistance of 200 ohms at a speed of 800 rpm. If the speed of generator is increased to 1000 rpm, speed increased from 800, then what is the change in critical field resistance? So remember, critical field resistance is proportional to speed of generator always. whenever the speed increases, no, whenever generator speed increase, voltage rating increase. Then if you draw the OCC curve, that OCC will shift towards upward direction. Then automatically slope of the line increases. That slope only, no, tangent of OCC is almost what? Critical resistance. That's why RC proportional to N it is. More speed, more critical field resistance. So initially it is 200 ohms for 800. Then if it is 1000 RPM, what is the critical resistance? Definitely more than 200. So there are two options with more than 200 here. So if you simplify it like this, RC2 by RC1 equals to N2 by N1. Then calculate RC2 equals to, what is initial resistance? 200. Now the new speed is 1000 divided by 800 it is. Then simplify, we get 250 ohms it is. Okay, 250. Next question. Read this question. Read the question. What is the question? When the supply voltage to an induction motor is reduced by 10%, the maximum torque decreased by approximately dash. See, in induction motor, many times in this ISRO examination, we have observed that there are so many questions many times from torque relations only. Torque relations, starting torque, maximum torque, okay, and also power relations of rotor input power, rotor copper loss, and gross mechanical power. So from these relations many times we have questions. So here maximum torque decreased by approximately dash. What is your answer? Your answer is dash. Voltage reduced by 10%. Maximum torque reduced by dash percentage. See, not only maximum torque, even starting torque, any torque you take, torque related to the voltage is square of the voltage. Okay, so here maximum torque they are asking, which is proportional to square of the supply voltage. Let initially there is 1 V1 square, then how much voltage is reduced? 10% reduced. Then what is the new value? 0.9 V1 square it is. Then how much it is? 0.81 V1 square we get. That means, so maximum torque is reduced by how much? 19% exactly. 0.19, no? So 0.81, initially 1 V1 square. But when voltage reduced, torque also reduced, it is 19%, but approximately they are asking from options is 20% it is. Right, next question. Read the question. The injected EMF in rotor of induction motor is of dash. So it is one of the speed control method of induction motor we use, EMF injecting method. So there are two cases in this. One is in phase injecting and out of phase injecting. Okay. So in any injecting method, maybe in phase or out of phase it is. So one important thing is, whatever the EMF we are adding or injecting into the rotor circuit, that voltage or EMF should have the frequency same as that of rotor frequency. So we are adding EMF to rotor circuit, no? We are adding EMF to rotor. And what is the frequency of rotor? It operates always at slip frequency, which is SF. Okay, so which is 1 Hz, 2 Hz, very low frequency it is. So whatever EMF we are adding into the rotor, that also should have the same frequency as that of rotor frequency, which is slip frequency. So the answer is the same frequency as slip frequency it is. Okay, so same phase, we have two methods, no? In phase and out of phase. Phase may be anything, but it should have the frequency same as that of slip frequency. Then only the signals will synchronize. Okay, next. Right, next question. If the full load speed of 3-phase induction motor is 950 RPM, then what is the half load speed nearly? So you answer this one. So this is a logical question, there is no calculations required for this. Tell me the answer for this. Answer. Full load speed given 950, then half load speed will be dash. Yes. Very good. See, from options you can eliminate easily. Always induction motor rotates near to synchronous speed, but not more than that, less than that synchronous speed. So always speed is what? Less than synchronous speed. Very near, not so much differ. Means here you can observe It is initially rotating at what speed? 950. So what is the nearest synchronous speed for that? 1000 rpm for 6 pole it is. 1000 rpm is the synchronous speed for 6 pole case it is. Now full load speed 950 means what is the half load? Load decreased. When load decreased, definitely speed increase. So more than 950, but less than 1000. More than 950, less than 1000 is only one option here. Option D it is. Right. Next question. See this question. For controlling the speed of induction motor, the frequency of supply increased by 10%, and for magnetizing current to be remains same, the supply voltage must be dash. See, whatever the concepts we know from transformer, almost same valid for induction motor also, like flux density relation, no, which is proportional to voltage to frequency relation here. So in order to have same magnetizing current, the flux density should remain constant, it should remain same or constant, it should not change. So given initially here, frequency of supply increased by 10%, frequency increased by 10%. Then when it is remains same, if you increase the voltage also by same 10%, then it remains same, so that magnetizing current remains same, which is from supply voltage. Okay, so what happens to voltage must be increased by 10%, right? Next question. Next. See this question. Read it. The speed of induction motor is controlled by varying supply frequency, keeping V by F ratio constant. Okay, V by F control method it is. Then from options here given breakdown torque and magnetizing current. So breakdown torque nothing but maximum torque only. So what is the relation of this? Answer. First answer from your side required. Maximum torque what happened and magnetizing current what happened? So V by F constant means what? Just now we have observed. Magnetizing current remains same it is. So magnetizing current remains same. But what about breakdown torque here? Yes. Breakdown torque nothing but maximum torque. So we have one relation. Maximum torque proportional to V1 by F whole square. V by F ratio whole square. And starting torque also there one relation. Remember somewhere we will use this again. It is 1 by F into V1 by F whole square. So these are all from torque equations we get these relations. Maximum torque only V by F square and starting torque 1 by F V by F square. Now whenever V by F constant, now what is maximum torque also? Constant. Means breakdown torque constant and magnetizing current also constant. That is breakdown torque and magnetizing current would both remain constant. Option A. Next. Next question. See the question. A synchronous generator connected to infinite bus is over-excited. Considering only the reactive power from the point of view of the system, the machine acts as dash. See, over-excited synchronous generator. What is the operating power factor? Over-excited synchronous generator always operates at lagging, and over-excited synchronous motor operates at leading it is. Okay, so over-excited synchronous generator here it is asking, so it is operating at lagging power factor. Over-excited, lagging means what is the nature of this lagging? Inductive nature, no? So it behaves as an inductor. Inductor it is. Next. Alright, next question. See the question. Which DC motor will have highest percentage increase in input current for given percentage increase in torque? Generally this question will little confuse. Okay, first you answer this. What is the answer? Tell me answer for this question. Answer. No. It is not series motor. Because in a series motor we know torque proportional to Is square, no doubt. But see here, for a given percentage increase in torque, which DC motor will have highest percentage increase in current, input current? See, whenever DC series motor taking a small current also, we get so much high torque it is. So high torque will generate for even a small current. Now if you take torque same, what is the current then? Suppose you take different motors, same torque, then which motor will take maximum or highest input current from supply? High current. So not series motor it is. Okay. For a small torque, it will take very small current. Suppose to generate some amount of torque, this one required, series motor required a very small current here. For a small current itself, we get good torque. Okay. Then cumulative compound also having so much amount of flux in that, shunt plus series. So answer for this is this one, which is torque proportional to product of flux into armature current. So here flux is almost constant, and even when reaction is taking place, some amount of flux may decrease here. So in order to generate some amount of torque, it will take high current here when compared to other motors, even separately excited motor. Compared to that, shunt motor little greater, but almost both are same, shunt and separately. But shunt motor will have little high current because in separately we can maintain flux almost constant. Even some reaction taking place, we can maintain flux constant by increasing little bit excitation there, but which we cannot increase, that is in case of shunt motor. That's why little current is greater for shunt motor here. So answer is shunt motor for this. Okay. Next. See this question. In alternator during hunting, when the speed becomes super synchronous speed, then damper bar develops dash. See hunting. So hunting phenomena is nothing but the speed of a synchronous machine other than synchronous speed. Maybe less than synchronous speed, also hunting, n less than ns, and the speed becomes more than synchronous speed or super synchronous we call, so which is also hunting. So any case, so in order to eliminate this hunting, particularly in salient pole machine, we use damper bars. Salient pole machine, we use damper bars. And what is the torque developed by that damper bars whenever the speed becomes super synchronous or more than synchronous speed? So which operation it is? N greater than ns is nothing but induction generator principle it is, and n less than ns is nothing but induction motor principle. Okay. So whenever speed becomes more than synchronous, it will produce an induction generated torque. Now what that torque will do? That induction generated torque, always generated torque is what? In which direction generated torque? In a generator, torque developed is always opposite to its direction of rotation. No? That's why now this induction generated torque will decelerate the rotor. Decelerates. Now this torque will decelerate the rotor because speed is very high. So because of this, now torque is developed, that torque will decelerate the rotor, means reduces the speed and becomes synchronous speed, so that hunting is eliminated. So the answer is here, induction generator torque it is. Next question. Read this question. Synchronous motors are not self-starting because dash. What is the reason for synchronous motor not self-start? So synchronous motor is having same stator structure like induction motor, three-phase induction motor. However, there is RMF, here also we have RMF, everything, but the rotor poles in synchronous motor are excited poles, not induced poles. Like induction motor, rotor poles are what? They are induced poles. So automatically torque will generate there, but not in case of synchronous motor. And due to heavy inertia of this rotor also, whatever stator poles RMF rotating, no synchronous speed. So whatever the speed the stator poles are rotating, that much speed is not possible for rotor at the time of starting due to high inertia of rotor it is. Okay. So here starting winding not provided, there is no slip. The direction of instantaneous torque on the rotor reverse after half cycle. So this is the answer for this, option D. Next question. Try to answer this. While conducting short circuit test on a transformer, the following side is short circuited. Now which side we short circuit? While conducting short circuit test, HV side or LV side? Actually, we can do the test, OC test, SC test on any side of transformer, we can do test actually. But due to some advantages only, we prefer to do OC test on LV side with open circuit on HV side, and short circuit test we prefer to do on HV side with short circuit on LV side. Now what is the question here? During short circuit test on a transformer, the following side is short circuited. Which side we short circuit? Test we do on HV side, means supply given to HV side, short circuit is LV side, low voltage side. Next, primary, secondary, this is not correct. Okay, next, see this question. The crawling in an induction motor is caused by dash. Crawling. What is crawling first? Crawling is nothing but it is the low speed operation of motor at some particular speeds, low speed operation. Suppose according to fundamental, suppose 4 pole case you taken, 4 pole 50 Hertz, then what is the synchronous speed? 1500 RPM. So near to that motors will rotate 1470, 1480, 1460 like that. But sometimes due to harmonic signals, particularly which harmonics are responsible for crawling of induction motor under running condition? Question is important, this one also. Like 7th harmonic is the reason for crawling of induction motor under running condition, normal running condition or motoring operation. And during braking operation, during braking, which harmonic is responsible for crawling of induction motor is 5th harmonic it is. Remember that. Now this crawling of induction motor is mainly due to harmonics developed in motor. Next question. See this question. The main disadvantages of using short pitch winding. Try to answer this yourself. The main disadvantages of using short pitch winding in alternator is dash. What is the disadvantage of? We use short pitch winding for some advantage, but there is one disadvantage also with this. What is that? Need your answer. Reduces harmonic in generated voltage, reduce the total voltage and produces asymmetry in the 3-phase winding, increases copper of end connections. What is answer for this? Yes, very good. So answer is it reduces the voltage around the coils. Actually, if you take full pitch winding, no? For a full pitch winding, what is the Kp? Pitch factor 1 it is. Alpha equal to 0, Kp is 1. So when Kp is 1, EMF will be little, magnitude is good. But when we use short pitch winding, what is the pitch factor value? Less than 1, some 0.9 or 95, 96 something. So whenever Kp is less than 1, the magnitude of EMF also little bit reduces there. So that is a drawback for us. Okay. So answer is option B for this. Next. Armature reaction in an alternator mainly affects dash. Armature reaction. Rotor speed, terminal voltage, frequency, generated voltage per phase. What is your answer? Armature reaction mainly affects dash. Here there are two possibilities. Maybe you can say voltage, terminal voltage, or also generated voltage. Which one we have to choose? Yes, no doubt we have to choose generated voltage per phase, because due to armature reaction we have a drop due to armature reaction in the form of reactance. We represent now armature reactance drop we call. So due to that armature reactance, some voltage will drop there, or we have demagnetizing effect. So due to armature reaction, one of the effect is demagnetizing effect. So because of demagnetizing effect, what happens? Some flux decreases, and because of that some EMF induced also decrease. So that is called drop due to armature reaction it is. And here whenever EMF of generator decreases, no, then what is the terminal voltage also decrease. Both are there, but which is the first responsible quantity for this is EMF. So EMF will decrease first, then only voltage will affect with this. Okay, next question. See this question. If the field of a synchronous motor is under excited, then the power factor will be dash. So you simply what you can do is, remember we inverted V curves of synchronous generator and synchronous motor. So both are same, but what is difference? Lag lead will interchange there. For V and inverted V curves of synchronous motor, this is power factor, armature current, and here we have field current. This is the V curve which is armature current, and this is inverted V curve which is power factor. Power factor versus field current, armature current versus field current is V curve. Inverted V is what? Power factor. So if it is synchronous generator, so right now it is motor here. So this is our normal excitation, this is over excitation, and this is under excitation. So over excited synchronous motor always operates at leading power factor. Under excitation operates at lagging power factor. Normal excitation operates at unity power factor. Okay. But if it is synchronous generator, no, this lag lead will interchange here. Now what is the question here? The field of synchronous motor is under excited, then the power factor will be dash. Under excited power factor is what? Lagging, no? So answer is option, right. Next question. See the question. Synchronous capacitor or synchronous condenser we call. No? So when a synchronous motor behaves as synchronous condenser or capacitor, over excited synchronous motor behaves as capacitor, no doubt. But pure capacitor is only under no load condition. Read here. It is an over excited synchronous motor running without mechanical load, means no load condition. And over excited synchronous motor driving mechanical load, an ordinary static capacitor and a rotating dynamic capacitor. So when it is a synchronous condenser or capacitor this is the perfect one for this. Without load or no load condition. Under no load it is a pure capacitor, but under load condition it is operating at leading but not purely capacitor it is. It is having RC, means this is unity power factor, no? 1, and power factor decrease 0.8, 0.6, 0.4 like this. But pure capacitor means 0 power factor. This is possible only with no load condition only. Okay, next. One of the main advantage of Swinburne test is dash. So one of the test in DC. What is the main advantage of Swinburne's test? Advantage. See, first of all, Swinburne's test is a no load test. No load condition we operate. So under no load when we operate, what is the power loss for us? Very, very less. And indirectly we will calculate efficiency there by utilizing the mathematical equation of efficiency, just by knowing rotational loss of machine here. So this is most economical and convenient test. It is very economical because loss during the test is very less. Like if you take brake test, no? So when we apply brake on the motor, so much heat will develop, so much power loss takes place in that. But this is economical. So power loss is very less in this. So this is answer for this. Next question. Read this. With V by F ratio keeping constant, if the frequency is decreased and voltage decreased proportionally, means V by F ratio constant, is fed to induction motor, its starting torque and maximum torque for variable voltage and frequency will be dash. So just now I given one equation. Starting torque proportional to what? 1 by F into V1 by F whole square. And maximum torque proportional to what? Only V by F whole square. So whenever V by F constant, this is V by F constant, so maximum torque also constant. But here frequency is what? Decreased. Frequency decrease and V by F ratio constant. V by F ratio constant but frequency decrease here. Then what is starting torque? Increases. So starting torque will increase and maximum torque remain constant, which is option B it is. Okay. So from equations we have to answer this. Right. Next question. See this question. This model of question also there repeatedly in ISRO. Read this. Power supplied to a 10-pole induction motor is supplied by 4-pole alternator which is driven at 1500. 4-pole alternator driven at 1500 means what is the frequency? 50 Hz only, no? The frequency is F equal to N into P by 120. That is 1500 poles are 4 divided by 120, we get 50 Hz it is. So alternator frequency 50 means same frequency we are giving to induction motor also. Induction motor having 10 poles. Okay. If the motor runs with the slip of 4%, motor is running with the 4% slip, the speed is dash. Now what is the speed of induction motor formula? N equal to Ns into 1 minus S. Now, so 10 pole case. For a 10 pole condition 50 Hz, what is the synchronous speed of induction motor? 120 F by P, 600 RPM into 1 minus 0 point, slip is 4%, 0.4. synchronous speed 600 means, remember, so directly also you can put without solving it is, synchronous speed 600 means the induction motor always rotates less than that, very near to that. Then what is only one option is 576. Directly also you can answer this. Now if you simplify, you will get 576 RPM. Okay. Next question. So induction motor supplied from alternator, and alternator driving at 1500 and alternator having 4 pole, accordingly 50 Hz it is. And same is giving to induction motor, and induction motor having 10 poles. Don't confuse in this. Next. What is answer? In a transformer, exciting current made up of, exciting current nothing but no load current. Actually we write it is as I mu plus IW, vector addition. Okay, and here they given as magnetizing current as IM in place of this IM, and iron loss component as core loss current as IC it is. Now with a negligible leakage impedance, V is the supply voltage. How that two currents related to supply voltage? We know if this is supply voltage, magnetizing current lags the voltage by 90 degrees, and iron loss current will be in phase with this. This is IW. So here I mu nothing but IM. IM lags voltage by 90, and IC means core loss component of current is in phase with voltage. So option C is the correct answer. Right. Next question. See this question. The residual magnetism of a self-excited DC generator is lost, means residual flux becomes 0. Then to build up its EMF, what to be done to regain the residual magnetism? So in order to build the voltage again, we have to recreate the residual flux, and for that one of the method we use what? Field flashing method. What is that? If you see that the field winding must be excited by low voltage DC supply. So only the field winding we will excite with a low voltage DC supply like this for some time. So once you excited, now field current will flow here, and after some time you remove that supply, again residual flux will be reproduced here. Okay, field winding must be excited by low voltage DC supply. So answer is D for this. Field flashing it is, field flashing method, field flashing. Next, read this question. A three-phase synchronous motor connected to infinite bus operating at leading power factor with a constant torque, load torque. If excitation is increased, the load angle and power factor angle. See, we know whenever excitation increase means field current increase, load angle definitely decrease. Load angle decreases. This is the curve. When excitation increase, load angle decrease, whether it is motor or generator, anything. Okay, load angle decrease, and it is connected to infinite bus bar operating at some leading power factor. But now whenever excitation increase, further increase, then what happens to that power factor value? Decrease. From inverted V curve you can see. Power factor decreases. Power factor decrease means what is the power factor angle? Increases. Okay, delta decreases but power factor angle increases. Delta decrease but phi increases. Option D is the correct. Okay. Next question. Next question. Read this question. Magnetizing inrush current in a transformer is rich in dash. So magnetic inrush current will flow during switching transients in transformer. Whenever the switch is closed at voltage 0 points, then it will draw very high magnetizing current. Okay, very high magnetizing current. That current only we call magnetic inrush current, which is unsymmetrical current. So in that, second harmonic is the most dominant current. Right. Next. Now see this. Two induction motor A and B are identical except that the air gap of motor A 50% greater than that of B. So two motors are there, A and B. So motor A having air gap 50% more than that of B. So air gap of induction motor A is more. So whenever air gap increase, what is the magnetizing current of A? Increase. I mu will be so much increase as magnetizing current to establish flux in that because of more gap. If I mu increases, no, automatically what is the power factor? Decreases. So induction motor A will have less power factor than B. So if you see the options, no load power factor of A will be better than B. So what is the answer? No load power factor of A is less than, no load power factor A will be poorer than that of motor B. Option B is the correct answer for this. Okay. Next question. Whenever air gap increase, magnetizing current increase, if I mu increase, definitely power factor of motor or transformer, anything, both are similar, no? Power factor decreases. Now see this question. Eddy current loss in a core of a transformer is dash. Directly proportional to resistivity, directly proportional to square of. So in terms of resistivity, how eddy current loss is related? If you remember equation, eddy current loss equation, which is K Bm square F square T square into V, volume. So here K is nothing but a constant which depends on the type of material, pi square by 6 into rho it is. So here K is depends on resistivity or conductivity of material. So resistivity, conductivity inversely related, no? Then you can observe, if you substitute here, the eddy current loss is inversely proportional to resistivity of material. Suppose if they ask conductivity, eddy current loss proportional to conductivity but inversely proportional to resistivity. So inversely proportional to resistivity, option D is the correct. Okay, next question. Next, series question. The capacitor start, capacitor run single phase induction motor is operationally a dash. Operationally, single phase induction motor we call. Okay, operationally, if you think operationally means whenever supply given, no, during its operation, it is not operating like a single phase induction motor, it is operating like a two phase induction motor, because a single phase induction motor is having two windings in that we know, we call main winding, auxiliary winding, and we are using some split phase techniques there, like resistor split phase, capacitor split phase. Mainly capacitor is preferred for better power factor and better starting torque. Okay. So whenever we use a single phase induction motor, operationally how it behaves is two phase motor it is. It is not single phase motor. Name is single phase, but its operation is always with two phase only. Two windings, no, main winding, auxiliary winding with a 90-degree displacement. Next. What would happen if the field of DC shunt motor is open? So whenever field winding open for a shunt motor, what happens to it? Whenever field open suddenly, then what happens to shunt motor? Speed will reduce, continue at normal speed, speed will be enormously increases, damaging the motor, none of the above. So we know whenever field is open, in a shunt motor, whenever field is open, what is the field current there? 0. Then speed is inversely proportional to flux. As flux is almost going towards 0, the speed will be dangerous high speed. Suppose if the same question is asked, a DC shunt motor is started with the help of 3-point starter, particularly specifically given like this. A DC shunt motor started with the help of 3-point starter. If suddenly field got open, if suddenly the field is open, then what happens to speed is it comes to stop. It comes to stop. So when there is a starter in the circuit, definitely motor comes to stop. Okay, that we know already from 3-point starter operation it is. Now here nothing is mentioned means we have to answer without starter anything. Then answer is definitely dangerous high speed it goes. Next question. Next. See the question. Equalizer rings in DC generator with lap windings are used for dash. So equalizer rings we use in which winding? Lap winding. Dummy coils we use in wave winding to make a mechanical balance of armature, but equalizer rings we use in lap windings, no? So why we use equalizer rings? Lap winding is having internally circulating currents between the parallel paths. To eliminate that circulating currents, so due to these circulating currents, we have some drawbacks like sparks will generate continuously at brushes, heavy amount like this. So to reduce that circulating current or to eliminate that circulating current between the parallel paths, we use equalizer rings in lap windings. Now here, equal distribution of current at brush for spark-less commutation, prevention of harmonics, reduction of noise, no, these are all not correct. Avoiding overhang, no. So answer is equal distribution of current at brushes for sparkless commutation. Okay. So whenever circulating currents are eliminated, no, automatically smoothly current reversal takes place. So commutation will improve there. Okay. Next question. Next. See this question. You try to answer this. A change of 5% in supply voltage to an induction motor will produce a change of approximately dash. Approximately. How much rotor torque will change? They are asking in the options. 5% change in supply voltage to induction motor. Approximately how much rotor torque will change? Answer this. Just now I given a torque proportional to always square of the supply voltage. 5% change given, but what change they did not mention. Means whether voltage increases or voltage decreases. You take anything. So torque proportional to 0.95 V1 square. 5% voltage decrease. Or you can take voltage increase. So it is approximately you get some 0.9 something V1 square. Means how much torque is reducing around here? 0.1 reducing, no, means 10% torque approximately. Or you take voltage increase also, means 1.05 V1 whole square. Then also 1.1 something, means around 10% only we get. So approximately the change in torque is 10%. Torque will change. Okay. Right. Next question. Next. If the supply frequency to transformer is increased, the iron loss will be dash. Iron loss. Supply frequency increases. Whenever frequency increases, no, what happens to hysteresis loss? But here it is not mentioned whether voltage increased or not. Then what is answer? Voltage not given. So let us consider if such cases is given, voltage is constant. Then if only frequency increase, V by F ratio will not be constant. Then WH is proportional to V1 power 1.6, F power minus 0.6, and eddy current is proportional to voltage square. So considering voltage constant, then as frequency is increased here, then what is hysteresis loss? Decrease. Eddy current loss remain same. Then what is overall iron loss here? So hysteresis loss decreasing, no? So overall iron loss will decrease here. So the iron loss will decreases. Okay. Next question. See this question. Two transformers connected in parallel share load in the ratio of kVA rating. Okay. Two transformers operating in parallel and they are sharing the load in the ratio of kVA rating provided their ohmic impedance. So there is one condition here. In order to share the load by two transformers in parallel proportionally based on their kVA rating, the ohmic value of impedance should be inversely proportional to its kVA rating. Ohmic impedance inversely proportional to kVA. And another condition is what? The per unit impedance of two transformers should be equal based on their own kVA rating. These two conditions. Same impedance condition in two ways. Ohmic value is inversely proportional to kVA and per unit impedance of two transformers must be equal based on their own kVA rating, not common kVA it is, remember. Okay. Now they are asking ohmic impedance, which is inverse ratio of their ratings. Inverse ratio of their ratings it is. Okay. Next question. Next question. And see this question. The high frequency hum in transformer is mainly due to dash. High frequency hum in transformer is mainly due to dash. Yes, there is more chance to put wrong option here. That is, most of the people will go with magnetostriction. Magnetostriction is the reason why noise is coming in transformer, but that is not the answer here. They are asking high frequency hum in transformer is mainly due to dash. Why we are getting so much humming or noise in transformer is due to loose laminations here. Okay, loose. If the laminations are loose, so much noise will develop there. If laminations are tightened with clamp support and all, then noise will reduce. So the answer is loose laminations for this. Next one. See this question. A 400 by 200 volt transformer has per unit impedance of 0.05. Z per unit equal to 0.05. Our percentage impedance is what? 5% it is. Okay. The HV side voltage required to circulate full load current during short circuit test. HV side. Generally short circuit test we do on HV side. And in order to circulate that full load current, we need to apply some reduced voltage or small voltage we have to apply. What is the HV voltage first here? 400 volts. But rated voltage we don't apply no, in short circuit test. How much voltage we apply in short circuit test? A small voltage. But how much? How much is it is exactly? Whatever percentage impedance of transformer is there, that much percentage of voltage we need to apply. 5%. Now what is the 5% of 400 volts HV side? What is 5% of 400? 0.05 into 400, nothing but 20 volts we have to apply. So if you apply 20 volts on HV side, then rated current will flow in the winding. So 20 volts we have to apply. Option A it is. Okay. Next. Taken? Next question. See this question. A synchronous generator is feeding power to infinite bus bar. A synchronous generator is feeding power to infinite bus bar at unity power factor, UPF. If excitation now increased, it will feed dash. If excitation now increased, it will feed dash. What is your answer? Initially it is operating at UPF, now excitation increases, then what happens to it? Tell me the answer. So here excitation is changing, but load not mentioned means load is almost constant, means same power it will deliver now also, but what is the power factor? Initially UPF no. So over excited now, over excited synchronous generator operates at which power factor? Lagging power factor. Same power but at a lagging power factor. Option B is the answer. Okay, right. Next question. This is also same as the previous. You try to answer yourself. Answer. The steam input to a steam input into a turbo generator connected to infinite bus bar increased. Steam input or mechanical input. Okay, steam input or mechanical input or load on synchronous generator, these are all same case. These are all same case. Which of the following events will take place? If steam input increase or mechanical input increase, then what happens to generator? If mechanical input increase, it will supply more power to the load. So generator will feed more leading kVAR or generator will feed more real power. So whenever steam input or load is changing, there will be a change in real power but not reactive power. Reactive power almost constant it is. Only when excitation changes, there will be changes in reactive power here. Now generator will feed more real power to bus bar and power angle will increase. And here also generator will feed more real power and power angle will decrease. So power angle or delta load angle will increase or decrease. Whenever mechanical input increase or load on generator increase, load angle definitely increase. So load angle increases here and generator will feed more real power to bus bar. So answer is option B for this. So such type of questions little will confuse in the actual examination. Okay, take care of this. See, according to my observation from synchronous machines, many times we have questions from parallel operation of alternator and particularly alternator connected to infinite bus bar case. Okay, so we have in parallel operation two important topics. One is two alternators operating in parallel and there are different cases, and another one is alternator operating on infinite bus bar. So this is majorly asked, alternator operating on infinite bus, and synchronous motor also similarly they asked, and V and inverted V curves. So this type of questions only majorly we have. Okay, next question. And see this question. The following data obtained by slip test on salient pole machine given ID max, ID minimum, VA max, VA minimum. What is the direct axis and quadrature axis? XD and XQ. XD, XQ we have to calculate. So in slip test, the purpose of slip test is what? To determine XD, XQ, direct and quadrature axis reactance. What is the equation for XD? See, during direct axis alignment, no, current required is minimum always, because whenever armature flux aligns with d axis, the air gap it sees is very less, small gap only along the direct axis. If air gap is minimum, what is the current required to establish the flux in that axis is very less, minimum current required, and voltage will be maximum at that time. So xd is nothing but maximum voltage divided by minimum, id minimum. And what is xq? Opposite. Directly you can take V minimum divided by IA maximum. IA minimum, IA maximum it is. Now you can substitute here, you will get the answer. Check what it is. Check which option is coming. Answer for this. Yes, 4.61 and 2.5 will come. Check it. Direct substitution. XD is V max. V max is what? 30. And ID minimum is, IA minimum is what? 6.5. 30 by 6.5 is this one. Check it. Check the values. Cross check. Next question. And see this question. A 4 kVA 400 by 200 volt single phase transformer has resistance and reactance given. Resistance is 0.02 per unit and reactance is 0.06 per unit. The resistance and reactance refer to HV side or dash. Actually, the per unit value remains same whether it is with respect to HV side or LV side. Okay, but they are asking, if you see the options is in ohms here. Now, what is one formula for this? So, formula for impedance per unit equal to Z in ohm into volt ampere divided by voltage square. Volt ampere by voltage square. Now, use this relation to find out this ohmic impedance from per unit impedance. So, we need resistance and reactance with respect to which side? HV side required, refer to HV side. Then what is the resistance value? Resistance in ohms required equal to resistance per unit 0.02 into voltage square with respect to HV side. No, voltage is 400 square divided by, so cross multiply this is ohms. This is per unit, directly I am writing here, 400 square by what is the kVA rating of this? 4 into 10 cube. Now simplify this. What is the answer? Resistance per unit how much? What is resistance per unit? Answer is what? Hmm. 0.8 ohms. So only one option is there with 0.8, directly you can put it. Next question. Next question. See this question. Two mechanically coupled alternators deliver power at two mechanically coupled alternators delivering power at 50 Hz and 60 Hz respectively. So one alternator delivering 50, other alternator delivering 60. Two alternators mechanically coupled. Okay, same speed they are operating. But we know alternator always operates at synchronous speed. No? Then what is the synchronous speed of first one? 120 into 50 divided by, so poles we don't know, poles of 50, and another one is 120 synchronous speed, 120 into 60 Hz it is delivering, that is 120 60 by poles of 60, both are same. So they are mechanically coupled. And what is the highest speed of that alternators? Highest or maximum speed is dash. Then if you simplify from here, P50, poles of 50 Hz alternator, poles of 60 Hz alternator is equal to 120 cancel. So 50 divided by 60 it is nothing but 5 by 6 it is. Now proportionally if you choose the poles, and poles never be odd number, so take the least integer is even 2, then this is 10 divided by 12. Then poles of 50 Hz alternator will be, you can take 10, and 60 Hz alternator will be 12. Then what is the speed? Ns equal to 120 f divided by 50 divided by poles of that is 10. Then if you simplify this, you will get 600 rpm. Or you can take with respect to 12 poles also for 60 Hz alternator, same 600 rpm only we get, 600 rpm. So two alternators mechanically coupled here. So they are operating at same speed. Which speed means synchronous speed. What is the synchronous speed? 120 f by p. Poles unknown for us, and that poles we derived like this. Okay, next question. Next, and try to answer this. A voltmeter gives 120 oscillations per minute when connected to the rotor of induction motor. Okay, voltmeter oscillations given means 120 oscillations per minute it is. Means what? Frequency only, no? Signal oscillating 120 oscillations per minute. When the stator frequency is 50 Hz, what is the slip of induction motor? Slip. See, rotor frequency nothing but slip frequency, which is 120 oscillations per minute, but frequency should be in per second. So 120 by 60 it is. So 2 cycles per second or 2 oscillations per second it is. Then what is the slip of the motor? 2 divided by, it is having 50 Hz frequency, 2 by 50, nothing but 0.04, no, 4% it is. 4%. Okay. Next question. 4%. Option C is the correct. Option C. Next question. Next. Try to answer yourself. A 6-pole 3-phase, same as this one problem also we have seen previous. This is in 18 again. A 6-pole 3-phase alternator running at 1000 RPM. 6-pole alternator running at 1000 means what is the frequency? 50 Hz, na, directly. For 50 Hz 6-pole synchronous speed it is 1000 RPM, we get 120 F by P. It is supplying power to a 8-pole induction motor. 8-pole induction motor, and which has a rotor current frequency 2 Hz. Means rotor slip frequency given. Rotor frequency nothing but SF, which is 2 Hz given. What is the speed at which the motor operates? So logically, if you answer, very easy it is. For 8-pole, no? Induction motor 8-pole, what is the synchronous speed? 120 F, nothing but 50 Hz, supplied from alternator, no, 50 Hz it is, divided by 8, we get 750 RPM it is. This is the synchronous speed of the motor, induction motor it is. Then at what speed motor operates? So SF given 2 Hz, from this you can find out S equal to 2 by 50, nothing but 0.04, 4% it is again. Then approximately you see the options here first. Options, directly you can answer. Synchronous speed to 750 means, what is the speed of induction motor always? Less than that synchronous speed. So what is less than 750 here? Only one option is there. Okay, no need other data here. If you understand what is the synchronous speed of induction motor rotates less than that, means 720 it is. Or you solve here like this, N equal to Ns into 1 minus S. Ns is what? 750. 1 minus 0.04. Simplify this, you will get 750 only. Okay, next. See this question. An electric motor with a constant output power will have torque speed characteristics in the form of dash. Torque speed characteristics. Constant power means we know power proportional to N into T product, no? 2 pi NT by 60. Power constant means what is NT relation? N is inversely proportional to T. So we get it is like a rectangular hyperbola relation, torque speed characteristics. So this is rectangular hyperbola. Okay. Next. So try to solve this yourself. So auto transformer related it is. Question only little lengthy, but with patience little bit slowly we have to read this. Nothing is there. Try to read. Given a 100 MVA single phase transformer rated 80 kV by 120 kV is connected as an auto transformer in such a way that dotted terminal of LV side is connected to undotted terminal of HV side. Dotted terminal of LV side, this is LV 80 kV, is connected to undotted terminal of HV side. Undotted here means dot here automatically. This is 120 kV and this is 80 kV. LV it is. And read the question. Undotted terminal of HV side. Undotted terminal of LV side is taken as common for both. Means this one, undotted terminal, no? This is common for both the sides, primary, secondary side it is. Then if you connect like this, additive connection it is 80, 120, nothing but 200 kV it is. So this is the auto transformer they are giving in the statement. Okay. Now 80 kV is applied to LV side. The rated voltage of 80 kV is applied to the low voltage winding of transformer, 80 kV here. This is 200 kV we get because addition it is. Now considering the transformer to be ideal and load to be such that the rated current flows through both primary and secondary windings, what is the kVA rating of auto transformer? So we have formula, kVA rating of auto transformer is what? kVA of auto transformer equals to additive connection 1 by 1 minus k times of kVA rating of 2 winding transformer it is. Then 1 by 1 minus k, what is the k? Low voltage by high voltage, 80 divided by 200, 80 divided by 200 into kVA rating or MVA it is given here, 100 MVA it is given 100 MVA it is. Now simplify this, we get 166.7 MVA or approximately 167 MVA it is. Okay, 167 means option D is the correct one. Okay, next. Now this is one of the important relation in induction motor. Regularly we have questions here. An induction motor operating at a slip of S, the ratio of gross power output to air gap power is dash. The ratio of gross power output, P gross, to the air gap power or rotor input power we call this. What is the relation? 1 minus S. Remember, rotor input power or air gap power is to rotor copper loss is gross mechanical power or rotor output power. The relation is 1 is to S is to 1 minus S. So any two relations they may ask you from these relations, any two from this. So answer is 1 minus S right now, 1 minus S. Okay. Now what is answer for this? A single phase transformer is switched on to a AC supply. In order to have minimum inrush current, the switch should be closed at dash. So inrush current or very high current will flow only when the switch is closed at voltage 0 point. So but we need here minimum inrush current. So in order to have minimum inrush current, we have to close the switch at voltage maximum point. Remember, we have to close the switch always at maximum supply voltage. Next. This is related to hysteresis eddy current. So you can solve this. Initially 200 volt 50 hertz, now it is 160 volt 40 hertz. V by F constant. Whenever V by F constant, no, what is hysteresis loss proportional to frequency? Eddy current proportional to frequency square. So use this relation and try to simplify this. You will get the answer. And here initial value is not given. So they are asking, read the question once. The hysteresis and eddy current losses of a single phase transformer working on 200 volt 50 hertz is just pH and PR given. Its value is not given. Okay. The percentage decrease in pH and PR when the transformer operates on 160 volt 40 hertz supply. So you take initially let pH1 equal to some 100 watts and PE1 equals to 100 watts. Anything you take. Percentage decrease means if you take 100 it is easily we get answer. Then according to this relation V by F constant, so according to this relation hysteresis proportional to F means WH2 by WH1 equal to F2 by F1. Now what is WH2? New hysteresis loss. Old one we taken 100 watts into new frequency 40 divided by 50 initial. So it is 80 watts. That means how much hysteresis loss reduces compared to previous? Previous 100 we taken, now it is 80. So percentage decrease is 20% decrease and automatically you will get 36%. Okay, C is the answer for this. Clear? Now see this. Double cage induction motors are used for dash. So why we use double cage motor? Particularly for a normal squirrel cage induction motor, the drawback is starting torque is low. But slip ring induction motor will have a good starting torque. We can also increase the starting torque by adding rotor resistance externally, some resistance to rotor externally. But in a squirrel cage induction motor, if you want to increase starting torque, there are some methods like that. In one of the method is this one, double cage rotor and also deep bar rotor. So this double cage rotor we use mainly for increasing high starting torque, or to get high starting torque we use this double cage rotor, special rotors it is. Okay, next. Okay, same as this you can solve this. Next question, see. So this is related to XD, XQ. So in a salient pole alternator, what is the relation between XD and XQ? Which is greater? XD greater than XQ always. Direct axis reactance is greater than quadrature axis reactance. XD greater than XQ, and the difference we call salience, you know. The difference of these two reactances we call salience. So direct axis armature reactance will be greater than quadrature axis armature reactance. Option A, XD greater than XQ it is. Next, loading capability diagram is generally drawn for dash loading. Generally this loading capability we use for synchronous machines. To decide its capacity we use this loading capability diagram for synchronous generator. Next one, you can see here, read the question. Assuming leakage flux to be negligible, when HV side of single phase transformer 100 volt 50 hertz 100 by 50 volt 50 hertz transformer is connected to 50 volts 25 hertz AC source, the core flux of the transformer. What happened? HV side, na, initially HV side is how much? 100 volt 50 hertz. What is 100 by 50? 2. Now it is connected to 50 volt 25 hertz. Now what is 50 by 25 also? 2. Means V by F ratio remains same. Okay, the core flux of transformer also same as that of rated flux only, it won't change. Okay, next question. Okay, this is previously we solved, no? Impedance per unit equal to Z in ohms into volt ampere by volt square. Use the same relation, you will get the answer for this. 10 ohms we get. Do this for LV side, it is they are asking. Same relation like previous question. Next, what is the answer for this? See, while performing short circuit test on a single phase 110 by 220 volt 50 hertz transformer with LV side shorted. Short circuit test performed initially with LV shorted, HV side supply given. Then wattmeter reading is what? 20 watts. The wattmeter reading is found to be 20 watts. If the same test performed on the transformer with HV side shorted now. Now this time HV side is shorted. As HV is shorted, then wattmeter reading will be dash. Means simply initially short circuit test performed on HV side. At that time wattmeter reading is what? 20 watts. Now the same short circuit test is performed on LV side, means HV shorted means LV side supply given. Then how much copper loss we get? Same answer, remember this. Whether you do the test, or if you do the test on HV side or if you do the test on LV side, the losses will never change. That may be short circuit test, that may be open circuit test. The losses remain same wherever we do the test. Okay, no? Next. Okay, see this question. For a three-phase slip ring induction motor, the electric rotor losses means what? Rotor copper loss only, no? Yes. Electric rotor loss is proportional to dash. Electric rotor loss is nothing but rotor copper loss. It proportional to what? From the given options, synchronous speed, air gap, power, slip, none of the above. If you remember, rotor input from the relation by rotor copper loss is equal to 1 by S. Then what is the rotor copper loss equals to? Slip times of rotor input power. Slip times of rotor input power it is. So, from here rotor copper loss proportional to rotor input only, no? Which is nothing but air gap power it is. Okay? Right. V curve of synchronous motor. So, V curve drawn between what? Armature current versus field current. Armature current versus field current. Option A. Okay. So, these are some important model of questions from previous year examinations of ISRO it is. Now almost same type of questions we can expect in the coming actual ISRO examination also. So try to prepare well, and important thing is presentation during examination is very important. Whatever you prepared now, that is not important. So during exam you have to present well without any tension, and read the questions properly without missing any data there, and answer properly. So all the best for upcoming examination.